Right. In question 5.1, given that the square root of 13 plus sine by sine x plus 3 equals 0, where x is an element of the interval that starts from 90 degrees to 270 degrees, the question says, without using a calculator, determine the value of this one, the value of the sine of 360 degrees plus x. Okay, so we need to find that one, the sine of 360 degrees plus x. Okay, the question is, how do we find the value of this? How do we determine this? All right, determine this, we use something that is very famous. We call the cast diagram. Right, there's something called the cast diagram.
Okay.
And it's very famous. I'm sure that you have seen that, but we are revising together. So I'm trying to make sure that we are on the same page and we refer to the same diagram. This diagram is called the cast diagram. It begins from 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 300 and what? And 60 degrees. Okay, right. And obviously it is a diagram that is very popular in school, and it is called the cast diagram. Okay, the C is for the cosine, the A is for the all positive, the S is for the sine theta, and this one is for the tangent of theta. Okay, now there are a couple of things that we expect you guys to know at matric, and it is really to say, in the first quadrant, you'll have 90 degrees minus x. In this quadrant, you will have 90 degrees plus x, but you also have 180 degrees minus x. Here you have 180 degrees plus x, but you also have 270 degrees minus theta. Okay, so you also have here 270 degrees plus theta, but you also have 360 degrees minus theta. Here you also have 360 degrees plus theta. Okay, so these are sort of the piece of information you need to have, and that is what you need to know. But most importantly, it's very important for you to realize that in the learning of trigonometry, when you move from 180 degrees to 270 degrees, you are adding to 180 degrees and hence the plus. But if you decide to go back towards 90 from 180 degrees, you are basically subtracting, and hence 180 degrees minus theta. This diagram is called the famous cast diagram. Okay, a couple of things then become extremely important for us to note, so that in that question there, in question 5.1.1, we're interested in the sine of 360 degrees plus x. So in question 5.1.1, we have the sine of 360 degrees plus x. And we're asking the question what the value of that is. First and foremost, we ask the question, in which quadrant is 360 degrees plus x? We can see that 360 degrees plus x is actually in this first quadrant. Okay, now I need to just recap on that. So this one is the first quadrant. This one here becomes the second quadrant. And this one becomes the third quadrant. And this becomes the fourth quadrant. So that if you have, for example, the sine of 360 degrees plus x, there it is, plus theta, there it is, okay? It is in the first quadrant where all functions are positive and hence the result is positive. And now at 360 degrees, there's just no co-function change. The function doesn't change there, and we have exactly the sine of x as it is. Okay, so this is what they asked the matrix of 2022 in November last year. Okay, in 5.1.2, we are asked to evaluate this one, the tan of x, the tangent of x. Right, so in 5.1.2, We're interested in finding the value of the tangent of x. Right, but now over to find the tangent of x, this one does not use any reduction formulae. This one uses something called the reduction formula. Why? Because we reduced the angle 360 plus to just an acute angle or an angle x, so it was reduction. Okay, right. So at this point, we have the square root of 13 sine x plus 3 equals 0. So we're given the square root of 13x plus 3, right, plus 3 on this square root, this result is what? Is equal to 0. All right, so this is what we get. And therefore, as a consequence, what does this mean? Right, so it means that we can move horizontally across the page and be able to write the sine of x. We transpose the 3, and if we do that, it becomes negative 3. We then divide by the square root of what? Of 13. And this is what we get. This question came in metric last year, but there was a typographical error in this question, but has since been rectified there, and therefore in the current version of the paper, it is not the case that the error is still there. Okay, right. So at this point, we expect students to note that the sign itself using so. The best you can do in these kinds of questions, always use a diagram. Okay, that is what I recommend. Use a diagram, because if you use a diagram, then you can't go wrong. Right, so we have this. Obviously, I'm going to be screening you as you go along. I'm going to be asking you a couple of questions. Right, so these has been given, but the examiner said x is an element of the interval from 90 degrees up to what? 270 degrees. Okay, that is what they said here. 90 degrees to 270 degrees. Right, so we jot that down here and we have that there, okay? We have the cast diagram. Okay, we have the diagram here, what you call the Argand diagram. Or what we call the Cartesian plane. Okay, right, so at this point, you need to realize that we need to first identify in view of our friends. So you write cast like this. That's what you do. You write cast. After having written cast, you ask yourself one question. The sign is what the examiner has given us, but it is negative. In which quadrant is this? It must be between 0 and what? It must be between 90 and 270. Right, so if this is 0, this is 90, and this is 180, and this is 270, and this is 360 degrees. Right, between 90 and 270 degrees. So where is 90? This is 90 here, and 270 is here, but the sign must be negative. So in which quadrant must this be? It can only be the third one. Well done. It can only be the third one, because in the second it is what? In the second it is positive. Okay, and it must be negative there. Okay, so we draw our triangle there like this. After we've drawn our triangle, we know that this is opposite over hypotenuse, and we measure this one here like this, x. So it is opposite. So opposite is the -3, and then the hypotenuse is what? Is the square root of 13. So we pick the opposite over the hypotenuse there. Okay. This is fantastic stuff. But now we realize that the examiner wants us to find the tan of x, but tan is opposite over adjacent. So it will have to be adjacent side is this one, which is the x. So we need to find x. So we remember from our old friend called the Pythagoras theorem. And that says that x squared plus y squared is equal to what? Is equal to r squared. Right, so we're interested in finding the x squared, but what is our y there? Our y is this one here. So our y is -3, which we square. Our r is this one here, and our r is the square root of what? Of 13, which we square. And this is exactly x squared plus 9 equals what? Equals exactly 13. So which means x squared is 13 minus 9. What is 13 minus 9 effectively? Right, so it is exactly 4, okay? And then after these, we have x squared equals 4. So we take the square root both left and right. We write plus or minus, which is plus or minus 2. Okay, so always put the plus or minus square root there. Right, so, but at this point, we realize that it can only be x equals -2. Why? Because we are dealing with x that is on the left, or on the left of the origin. On the left of the origin, x is negative, otherwise x is positive this side. Okay, so what does this mean? It means we're in business then, the Waruna. Right, so we continue and we say the following. Right, then we say the tangent. The tangent of what? The tangent of x, which is what the examiner wants. Okay, the tangent of x is exactly opposite over adjacent. Opposite over adjacent. What is the opposite? Opposite x is the y, which is -3. The adjacent is the x, which is -2. And therefore, the answer is 3/2, and that is the answer.
Okay.
Okay, yeah. Okay, very easy. But I know there are billions of ways to do this. Maybe we should have done it like in one step. Okay, I'm also going to look at some shortcuts. Okay, there's some shortcuts we can use so that we get these very fast, because I know very well that you guys are still in school. And therefore, I'm at university myself, and that is the reason possibly why you are referred to me, because I'm at university. I work for the University of South Africa, but I'm a researcher at the University of the Witwatersrand in Johannesburg. Okay. And so I'm a mathematician there. And that's the reason why you referred to me, okay, because I tutored for a couple of years. I came across your granny there. Okay, right. So let's look at the next one. Okay, so these things, you're going to have a chance to write them down at the end of the lesson, okay? In 5.1.3, because you need to write the questions down and the answers, okay? But now we're just having a discussion, and I know very well that I might be moving at a slightly faster pace, or I'm just looking at these, but I'm going to send you the link to the lesson a few minutes afterwards, so that you can write down the questions and the answers for practice purposes and for the future and for exam revision. Okay, right. So let's look at this one. Now we're dealing with cosine of 180 degrees plus x, and we're asking the question, in which quadrant is that one? Okay, and obviously at this point, that is what we just need. We just need to know exactly these. So what do we do here? We have the cosine of these, so 5.3. Right, so to deal with the 5.1.3, we have the cosine of 180 degrees plus x. In which quadrant is this one? 180 degrees plus x. So we look at this diagram. 180 degrees plus x is this one, which is the third quadrant. And the third quadrant, only 10 is positive. So all the other functions are negative, meaning this one is also what? Is also negative. So it means the cosine is also what? Negative, excuse me. Okay, it's negative, but it is negative what? So it's negative cosine x. Okay, that is what we get there. It is exactly negative cosine what? Cosine x. All right, so that is what we get there. Right, after having obtained these, we ask ourselves the question here in 5.1.3, in terms of what the answer is going to be to this. Okay, so obviously, remember that we are actually given this here. We're given exactly this. So if you're given that, you can further simplify these and say, for example, so you have the negative. What is cosine x from the diagram? Okay, cosine is what? Using the SOHCAHTOA. So adjacent of hypotenuse, right? So this is going to be adjacent of hypotenuse, and therefore the adjacent is what? Is -2. The hypotenuse is what? Is the square root of 13. And therefore the result is that it becomes 2 over the square root of 13 there. Okay. And that is what?
I have a question.
Yes, what's your question?
So we were taught that cos can never be a negative. So are we allowed to write it down like that?
Yes, that's a good question. Cos can never be a negative. Well, I mean, that's an interesting point, but the truth is cosine can be negative. Why? Why? Okay, because of the cast rule. Because now, for example, if you get the cast diagram says cosine is only positive in each quadrant. Well, it's positive in the fourth, and all are positive in the first. So it means that cosine is positive in 2 quadrants. It means that the cosine is positive in quadrant 4 and quadrant 1. What about in quadrant 2? Or what about in quadrant?
Negative.
Or what about in quadrant 3? Please come again. What about in quadrant 3? Is in quadrant 3, what function belongs to quadrant 3? Is the tan, isn't it?
Yes.
So what about cos in the third quadrant? Is it negative or positive?
Negative.
It is negative. So yes, it can be negative. I'm not sure if I'm answering your question there.
Okay, yes.
Well, I hear you, but it can be negative, provided maybe I don't understand your question. You get the point.
Yes.
Okay, right. Okay, that's fine. We shall, I'm sure, understand as we move, as we go along. Right. If you look at 5.2, determine the value of the following expression. Without using a what? A calculator. All right. Now I want to also do this one of 5.1.1 properly. Okay, I want to mention something in 5.1.1. Let me see. Right. Now in 5.1.1, obviously we use the reduction formulae, but I want to state something more. Because at this point, you realize, therefore, that you have the sign of x. What is the sign of x according to this diagram? What is the sign of x according to this diagram? Right, sine x according to this diagram, according to SOHCAHTOA, the sign is opposite over hypotenuse. So at this point, which means it is opposite over hypotenuse, which is y over r, which is -3 over the square root of 13. So it is opposite over hypotenuse, which is -3 over the square root of what? Of 13, for example. Okay, so now this is just one thing I need to mention, obviously, before we just move on there. All right. Moreover, I want us to look at 5.2, determine the value of the following expression without using calculator. For example, in 5.2, if I'm to look at the cosine of this, 5.2. Right, so let's look at 5.2. Right, so 5.2 is a very interesting one. And here it is. 5.2 begins as follows, and it says the cosine of 90 degrees plus theta divided by the sine of theta minus 180 degrees 3 into the sine of minus theta. In which quadrant is 90 plus? Okay, so we go back to the Gauss diagram.
The second quadrant.
It is in the second quadrant, right? And in the second quadrant, we have cosine there. Is the cosine positive or negative there? It is surely, it is negative, so it can be negative. Okay, so it is negative in the second quadrant. All right, I'm happy that you said it's negative. I agree with you. So the cosine is negative there, but we remember that it must change to its co-function. We use something we call the Coco rule.
Okay.
Right, using the Coco rule says that if you have cosine theta, and then you have, for example, sine theta. Right, the Coco rule says the following. It says that if you have a co, you remove the co, and you're left with sine. And therefore, this is going to become, because it has a co, the cosine has a co, so it becomes the sine of theta. But it's all divided by the following. In which quadrant is theta minus 180 degrees? All right, so this one, now you need to think deeply. So the best is a couple of things that you need to consider. So minus 180 degrees is a negative angle. So what you can do, you can factor out a negative and then have 180 degrees minus theta like this, okay? And then, so that you can have a positive angle, but yeah, I'm gonna look at other ways to deal with the negative angles. Okay, which quadrant is minus theta? Minus theta is considered to be in the fourth quadrant. If you look at minus theta like this, is measured in a clockwise direction. So angles measured in a clockwise direction are negative, and therefore is in the fourth quadrant. The minus theta is in the fourth quadrant, and therefore in the fourth quadrant, the sign is what? Is negative. So it becomes negative the sine of theta. Okay, right. So what is this here? So this is minus the sine of theta, all divided by the following. Okay, look at this. Now, if we have a negative like this, the negative means that we're in the fourth quadrant and the sign is negative. So it becomes negative the sine of 180 degrees minus the theta minus 3 the sine of theta. Okay, what is all this? Which is minus the sine of theta divided by. In which quadrant is 180 minus theta? So now 180 minus theta, in which quadrant is it? So 180 minus in the second quadrant. And the second quadrant, we have the sine function, and therefore it is what? It is positive, but we already have a negative, so it's just gonna remain positive like this, okay, with a negative in front. So you have that, okay. So this is minus the sine of theta, all divided by, what is minus sine theta minus 3 sine theta, which is minus 4 sine theta. Okay, now look at this. So the sine cancels out, leaving us with 1/4, and that is the answer. So the answer is 1/4. Any question?
No.
No question.
I understand.
Oh, you understand?
Yes.
All right, I'm delighted. Okay, many thanks then that you understand. Then can we move forward?
Yes,
all right.
we may.
Okay, thank you. Thanks a lot. Okay, right. So we move to the next question. Where are we? We're in 5.3. Determine the general solutions. I want us to discuss a concept we call the general solution of the following equation. Right, the following equation is this one here, which is cosine x plus 2 sine x into 3, the sine of 2x minus 1. Right, 5.3, the general solution equals 0 for 6 marks. Okay, so let's look at this one because it's just coming in the prelims. it is coming in the prelims. It will come like like in a dream, you know, because it will just appear when some people are still thinking the prelims are too far, the trials, the trial exams. Okay, so now you have the cosine of x into the sine of x, which is 3 the sine of 2x minus 1, which equals what? Which equals 0. All right, this one is easy because it's already been factorized and we just have to solve this. Very, very straightforward. Right, to solve this one here, it means we're gonna do the following. So we're gonna take the first binomial expression, the first pair of parentheses, and we write cosine x plus 2 the sine equals 0. Or we have 3 the sine of double x minus 1 equals what? Equals 0. And now, what is all these here? This is exactly cosine x, which equals minus 2 the sine of x. Or it's actually telling us that the sine of x is we transpose the 1, making it positive, and then we divide by 1/3, by 3, making it 1/3. At this point here, we divide this one by cosine. Okay, divide by cosine, so, okay, you can do two things here at the same time. So we put the equal sign like this. You have the sine of x, divide by cosine x. And then, after having divided by cosine x, you're left with 1 here. You divide by negative 2. This is 10x. Okay, you'll ask me if you have the questions, etc. Okay, so that is what we get. So we have these two equations we need to solve. Now to solve these equations is straightforward. How do we do it? Right, we first find two things we call the reference angles for each one. Right, so the reference angle of the right is the arc sine of 1/3, and we get the answer. Okay, now we find so we're going to use our calculators here. All right, and then we need to use our calculators. Obviously, we have to. Okay, let's see it there. All right, so for this one, we find the reference angle. Right, the reference angle of this one here, you note that for us to find the reference angle, we write arctan of positive 1/2. Okay, so what is, so you see it is negative here, but here we put a what? A positive. Okay, so if we say arctan of 1/2, the calculator is going to give you 26.565 degrees. Okay, what is arc sine 1/3? Arc sine 1/3, the calculator is going to give you 19,471 degrees, approximate. Okay. Now, we're interested in the general solution. And now, here is this one. So the general solution has the following things. We put the cast like this. We say now, right, so the sign is positive. So in which quadrant is the sign positive? Right, so it is positive in the first, but it's also positive in the what? In the second quadrant. Right, so because it is positive 1/3. So the result must be in the first quadrant. In the first quadrant, the angle here, for instance, becomes an acute angle. And the angle here, measured like this, becomes something called an obtuse angle. So we have those two angles there. Okay, right, so we continue and we solve. Okay. I don't normally show my picture, but there are times when I'm going to show my picture, but yeah, I normally just show my profile picture. Okay, my screen just rotated. All right, never mind. All right, so okay, right. So we have this, and then what is our x then? All right, so this is what we get. there. So we're able to see, therefore, that 2x is the acute angle, which is 19. So it is exactly 19,471 degrees. And then now we look at this. So we add 360 degrees multiplied by k, where k is an element of the set of what? Of integers. All right. So we're dealing with the sine function, and the period is 360 degrees. We divide by 2. And if we divide by 2, what is 19,471 divided by 2? It is exactly 9,74 degrees. We divide 360 by 2, it is 180 degrees times k, where k is an element of the set of integers. Okay, so this is what we get. But now this one gives us an answer in which quadrant? This one gives us an answer in quadrant 1. Okay, right. And then why quadrant 1? Because 19,471 is an acute angle in the first quadrant. Okay, how do you see an acute angle? An acute angle is an angle between 0 and 90 degrees in size. So surely the angle 19,471 is an angle between 0 degrees and 90 degrees, which is acute. Okay. So it is smaller than 90. It is smaller than 90. Okay. 19,471 is smaller than 90 degrees. Okay. Right. So we continue and we find one more angle. So to find the other angle, we say 2x, this one, 2x, this one, is equal to the next angle. We found one which was in the first quadrant. The next one is in the second quadrant. How do you find the second quadrant? You say 180 degrees minus the acute angle. Now we want to find an angle in the second quadrant. So in the second quadrant is 180 minus. 180 minus 19,471 degrees. Okay, so I need to clean this up. Okay, 19,471 degrees. And then we must add the period, multiples of the period of the sine function. All right, and k is an element of the set of integers. So this is 2x. So you have 180 degrees minus 19,471 degrees, and you must get the results, okay? So let's get the result. So to get that result, you must say 180 degrees. I'm having my calculator 19.471 degrees. That is 160.53 degrees plus 360 degrees by k, where k is an element of the set of integers. You divide through by what? By 2. And if you do, you get divided by 2, you get 80.26. Okay, so you get exactly 80, 260 degrees. You divide 360 degrees by 2. It gives you 180 degrees by k, where k is an element of integers. I'm going to give you assessments where I'm going to test your understanding, okay? I understand that obviously I'm the one now just discussing these things, but your turn is coming to demonstrate to me that you can do these things and you can solve the questions. Why trigonometry today? Because your granny told me that you are interested a bit in trigonometry and functions and graphs for a start, okay? And then we shall then do the rest of the other sections. Okay, now this one tells us here, the sign is the tan of x. The tan of x is minus 1/2. Okay, what quadrant is this one? Okay, so this one is in which quadrant? So tangent is negative in the second quadrant, but it's also negative in the what? In the fourth. Okay, so it is positive in the first because all are positive in the first, but the tangent is also positive in the third quadrant. Okay, now let's continue like this. Let's say the following right now. So we want to get an angle that is in the second quadrant because that is where we have that the tangent is negative. How do we do it? Using this a reference angle. So we're going to say x first. So we take x. So x is equal to, so we take 180 degrees, and then we minus, because 108 degrees minus is in the second quadrant. We minus 565 degrees plus 180, because it's the tangent. We have the tangent, so we must add 180. So we add 180 degrees times k, where k is an element of the set of integers. Okay, so this is what is 180 degrees minus 20. Okay, so it is exactly 153,43 degrees plus k times k times 180 degrees, where k is an element of the set of integers, and that gives us just a general solution there. That is what the examiner wanted from the students, but we can get more. You can get more. How do we get more? Okay, we get more because this 180 degrees minus is in the second quadrant. Okay, but now we need to get another solution that is in the fourth quadrant. So in the fourth quadrant, because the 10 is also negative there in the fourth, so how do we get the one in the fourth? So we shall use the reference angle, but now we must use 360. So you must say 360 degrees minus. So this is 360 degrees minus 26, 565 degrees plus 180 degrees times k, where k is an element of what? Of the set of integers, which means x is the same as, what is 360 degrees minus that? Minus 26,565. So that is 333,43 degrees plus, okay, plus what we add? We add 180 degrees times k, where k is an element of the set of integers. So this is what we get, and that is the result. Okay, so we have two results there. So these are the general solutions. What are the general solutions that we got? So the general solutions that we got are exactly these ones we have obtained. So it is this one here. It is that one there. 2. It is this one here, 3. And it is also this one here. Okay, so we found these general solutions and we're excited. We found 4 pieces of these general solutions and we are happy. Okay, so that's pretty much the answer. This lesson is recorded, so you'll have access to these at the end of our lesson to watch for the whole year, etc., etc. You know, you can watch in November, you can watch the day before the exam. I'm going to upload the video online. Okay. All right. So good things. Right. I'm trying to look at trigonometry because they told me, hey, Waruna is just interested in trigonometry. Okay. Now, I know trigonometry is one topic that is a little bit itchy to the students. They get this one because at university, you need this to do engineering, to do science. I'm a lecturer at varsity, and the truth is, I tell you the truth, that if you understand trigonometry at school, you'll have no problem at varsity because it's a lot at varsity, but at varsity, you're doing other things. You're doing engineering, you're doing technology, you're doing medicine, you're doing chemical engineering, where these things come in. Okay, right. For example, if I look at 5.4, given the identity, this one, the cosine of x plus y times the cosine of x minus y equals this. These identity. How many marks? 4 of them. Let's look at 5.4.1. Let's look at 5.4.1. Right, so 5.4.1. Okay, all right, so we're looking at 5.4.1. Want to prove that identity? Let's prove it. Now to prove this identity, you take a side. So we're gonna let the left-hand side. We're gonna let the left-hand side be the cosine of x plus y into the cosine of x minus y. Right, so we remember something we have learned about what we call the compound angle formulae. Cosine x. Okay, the cosine of x plus y. The formula is at the back of the metric paper. But cosine of x plus y is cosine x times cosine y minus sine x and x and y. Okay, so that is there. There's another compound angle formula for the cosine of x minus y, which is cosine x, cosine y, plus the sine of x, the sine of y. Okay, good there. So we proceed with our simplification. What does this mean? So we use a method we call the FOIL method. So I'm going to multiply this with that. And we call those the first. Right, and then after multiplying those, I'm going to multiply these with that. We call those, for these ones are called the what? The first, and those are called the outers. Then you multiply these with that. They are called what? Inners. You multiply these with that. They're called the what? The last. The last ones. Okay, I mean, I'm excited. Right, so let's look at this one. Cosine x times cosine y, cosine x times cosine y. So it is cosine x squared, cosine squared y. Okay, so we're multiplying those, the first ones. And then after that, we multiply the outers. Okay, and the method is called what? It's called FOIL method. It's called FOIL method of multiplication. All right, so we multiply then the cosine times the sine, so which is plus cosine x, cosine y, sine x, sine y, minus sine x, sine y, cosine x, cosine y, and then, yes. So you multiply this with that. I did the outers, then I did the inners, like that. And then the last. So the last would be these ones for the last. Right, so the sine, which is sine squared x, sine squared y. Okay. It's complicated. It's messy, I know. You will forgive me because I know. Okay, it's the identities look a bit messy. Okay, they don't look so tidy. Okay, now this one has sine x, sine y, sine x, sine y. It has cosine x, cosine y, cosine x, cosine y, and these things are just subtracted, and these things give us 0. So they just like terms just with a minus in the middle. So we're left with cosine squared x, and then cosine squared y, then we have sine squared x, then we have sine squared y. Okay, so that's what we get. That's what we can get. The left inside. So now we have this. We have this. So so it's very important that when you watch your lesson on the cell phone, you make your cell phone landscape, not portrait, horizontal and not vertical. Okay, for adequate, yes, because if your cell phone is horizontal, then you can see very well, because if it's horizontal, then we call that landscape. But if your cell phone is vertical, then it's portrait mode. Portrait mode is not the best mode when it's vertical, but when it's lying down, then normally you have a better view and a larger screen to view. Okay, right. So let's continue. Now, we remember something from grade 10, grade 11. Right, we remember something from grade 10, grade 11. What did they teach us there? They said the following. This is the law of unity. This is called the Pythagorean identity. Right, so they taught us that if you have the cosine squared of x plus sine squared x, the result is always what? It's always 1. Good, thank you. It means that if I want to write cosine squared x, I can say cosine squared x is 1 minus sine squared x. So in the place of cosine squared, we have 1 minus sine squared x. And then we have cosine squared y. We have cosine squared y. So what is cosine squared y? We can do the same. Cosine squared y is 1 minus sine squared x. Minus. Right, so this is what we get. This is what we get. And then now we're going to have sine squared x. We have sine squared y. All right.
I have a question.
Yes, good.
Why is the second bracket not 1 minus sine squared y instead of x?
Thank you so much. I can see that you are wide awake. Because it has a y, isn't it? Yeah. Because there's a y here. So it must be y there. True. So you're fine now?
Yes.
Thank you for being smart, okay? So you proceed. Right, so the next thing is we multiply out using the FOIL method again. So we're gonna multiply 1 with 1. What is 1 by 1? It's exactly 1. Then you multiply this by that, which is minus sine squared y. Then multiply this by that, which is minus sine squared x. And multiply this by that, which is plus sine squared x sine squared y minus sine squared x sine squared y. Okay, and therefore these two guys here, they cancel out. They look like good friends of each other because they are the same. Okay, right, so we then have 1 minus sine squared y minus sine squared x. Okay, and this is exactly, it is pretty much, let's see, 1 minus sine squared y minus sine squared x. Let's see what they got. The examiners, see what they got. They got 1 minus sine squared x minus sine squared y. Okay, which is pretty much what we are close to, but just commutativity. So it's 1 minus, they started with sine squared x and then they wrote sine squared y. Otherwise, this is the right-hand side of what they got. So it means, therefore, this left-hand side is 1 minus sine squared x minus sine squared y. It is the right-hand side. And now we do this, you get your full marks, and you come to Vet University and you meet us doing science and research, okay? All right, because if you get these right, then you can do engineering at varsity. You can do whatever, science. Okay, but the requirement at varsity is you need level 7 in math, or level 6 if it's not good enough. Okay, but obviously I'm here to screen you. I'm here to give you assessments to see the level you're gonna get, so that we can know now how prepared you are. Obviously, those assessments are still coming. I'm gonna send you those assessments. You're gonna do them, and then you're gonna send me screenshots, pictures of those assessments. I'm gonna mark them, and I'm gonna know how well you can do in math. Okay, right. So let's look at the next question. The next question is, you're going to be on your screen until 10 something. Okay, I wrote the time at the top. So we've proven the identity, and now the examiner continues to say, hence determine the value of 1 minus sine squared 45 minus sine squared 15 without using a what? A calculator. How many marks? 3 marks for that. Okay, let's just see. This one is pretty easy and straightforward. Let's get the marks and get the distinctions. So 5.4.2. Okay, 5.4.2. Now in 5.4.2, you're going to proceed like this. I'm just going to leave that little part there. So we're going to say 5.4.2. Right, in 5.4.2, the examiner gave us 1 minus sine squared of 45 degrees minus sine squared of 15 degrees. What is these? You need to remember something is good. You need to recall that this one, they said hands. If the examiner says hands, they mean use the result you got from above. They said hands because they know that we had just proven that the cosine of x plus y, the cosine of x minus y, which equals 1 minus sine squared minus sine squared like this. Okay, so what does it mean now? It means that this is our x in that identity here, and this is our y in that identity. So we can therefore write this one as x, cosine of the x, which is 45 degrees. Okay, and then it is x plus y, so it is plus 15 degrees because it's x plus y, and then it is x minus y, which is the cosine of x, which is 45 degrees, minus y, which is minus 15 degrees. So this is the cosine of, what is 45 plus 15? It's 60. So this one is going to be exactly 60 degrees. So you can do that one of 60 degrees. So you can do cosine of 60 degrees. And then here we have 45 minus that, minus 15, which is exactly 30 degrees. Okay, after we go this one, we remember our good friends, the special triangles, because we have the special angles here. Right, so what is the special triangle? It goes like, it goes this way, and it goes this way, and we do this. So at the end of the day, this is exactly 2, this is exactly the square root of 3, this is 1, this is 6 degrees, this is 30 degrees. So what is the cosine of 60? Okay, we use SOHCAHTOA. The cosine of 60 degrees becomes adjacent of hypotenuse at 60. So adjacent 60 is 1, the hypotenuse is 2. And then you look for the cosine of 30 degrees. 30 degrees is this one. And adjacent 30 is equal to 3 over the hypotenuse is 2. Okay, so we just to simplify these things here, and this gives us the square root of 3 out of 4. And this is the answer. So it tells us, therefore, that the answer to the 5.4.2 question is the square root of 3 out of 4. We done. Okay, we're excited, but there can be many other ways to do it. Okay, billions of ways to do exactly this question here. So we are so good, but so good. Okay. Right. Like I said, this lesson is recorded, so is being recorded, so you shall have the recording to watch. Okay, 5.5. Consider the trigonometric expression. Right, the trigonometric expression, which is exactly 16 sine x times cosine cubed minus 8 sine x cosine x. Rewrite the expression as a single trigonometric ratio for how many marks? For 4 marks. So in other words, combine everything, but leave nothing. Leave no stone unturned. Okay? Everything must be made single. It's like you have a binomial here. Okay, we have a term here. We have a term, yes, which is a product of some terms, and we have another term here. And now they're saying make this term, two terms, one single trig ratio. Okay, let's proceed. Right, it's an interesting journey, because that is what the examiners want to give you. They want to give you a distinction so that you can go to varsity and do medicine and do the kinds of things you want to do. But now remember that university has one rule, that you must pass your math. If you pass your math, then they're going to take you at varsity, because at varsity for science and engineering, the rule is one. They're saying if a kid can pass math at school, then they can succeed at varsity. But if they cannot get level 7 or level 6 in math, then they can't manage university, and that is the rule. So they need to stay at home. I'm sure that is not your wish to stay at home, so you need to join us at varsity. Okay. So where are we here? We want to make this a single trigonometric ratio of x. How to make these just one thing, but one thing. Okay, it looks very messy, and we need to go back to grade 9 and remember what they taught us in grade 9. In grade 9, they taught us the highest common factor. Highest common factor. So we need to factorize here by taking out the highest common factor. So we're going to take 8, because 8 is the highest common factor of 16 and 8. All right? And then now the highest common factor of sine x and sine x is just sine x everything. The highest common factor of the cosine cubed and the cosine x is cosine x. Okay, and then we close the brackets. Now you divide the 16 by 8. What do you get? You get 2. Okay, now there's the trick to factorization. The kids forget this, the matrix. Okay, you pulled out sine x, just cross it out. So sine is gone. And then now you are dealing with, you pulled out cosine. You pulled out cosine x. So cosine, 1 is gone, you're left with 2 of them. So here you're going to have 2 squared. We have 2 cosine squared minus what? Minus 1. All right. So there we go. There we go.
Why do we have a 2?
Okay, that's a good question. Why do we have a 2? Okay, there are 2 of them. You mean this one or the top one?
The red one.
Okay, the red one. Okay. Right, the red one, we have a 2 there because we divided 16. So if you factorize, we factor out the 8, you divide 16 by 8, and you then say 16 divided by 8. What is the result? It's 2. Okay, and that's what we get there. Right, so we have this. So what do we get this to be? So it is 8 the sine of x cosine x. What is 2 cosine squared minus 1? It is an identity, double angle formulae. Okay, the double angle formulae, what are they? If you have cosine 2x, it is 2 cosine squared x minus 1. Right. Cosine 2x is 1 minus 2 sine squared x. Cosine 2x is also cosine squared x minus sine squared x. So cosine 2x is having 3 identities there. So if you have this one, 2 cosine squared minus 1, it is cosine 2x. So this is cosine 2x. Okay, good. Now we have this. Right, now we're in business with this. So what is all this stuff? Okay, this is all good news to us. Good music. It's good, good music. Right, it's good, good music. Let's see what we get. Right, so what does this mean? What does these all mean? So it means the following. It means that here we can have 4 into 2 sine x, cosine 2x. Right? So we have done this because 4 times 2 is 8. Okay, that is why we just factorized here. But there's another identity we learned. These are called double angle formulae. The trigonometric sine of 2x is actually 2 sine x cosine x. So this is the 2 sine x cosine x is sine 2x. Cosine 2x. So now,
How do we know which one to use?
how do we know which identity to use, right? All right, so we always read the situation, like if somebody says, how do we know whether to cross the street or not in the presence of traffic? You'll tell the person that, okay, you watch the traffic lights. So if the traffic light is green for pedestrians, it can be green for pedestrians or green for cars or green for traffic. So if it's green for traffic, then the traffic obviously should move. So you watch the signs and what you do. For example, here we just had what? Sine, cosine. And this is only one identity that is sine, cosine. Is the sine 2x identity. Because sine 2x is 2 sine x cosine x. So if we have sine x, cosine x, then now we factor out the 8 because sine x cosine x must go with a 2. So we factor out a 2 from the 8. And then we have 4 times 2. Right, so we have 2 sine x cosine x. What is 2 sine x cosine x? 2 sine x cosine x is at the bottom of the screen. 2 sine x cosine x is exactly the same as what? Sine 2x. So you can see we need to use that one. But there's a small trick here. We have something. We have sine 2x cosine 2x, but there's a 4. We must make this 4 2. So I'm going to break 4 down to 2 times 2 sine 2x cosine 2x. So what is 2 sine 2x cosine 2x? Right, so if the minute we have 2 sine something cosine something of the same, it becomes sine of double the angle. So this one is going to become the sine of double the angle 2x. Okay? Which is the sine of 4x. Is the sine of 4x. Okay, so that is the sine of 4x, and that's the answer. All right, so it looks messy, but you'll understand. You'll understand, please, as you move along. So what have we done? Now, these we have simplified to a single trigonometric ratio, but most importantly, there's no further simplification that is possible out of this. We have got to the end. So, well done to us. Okay, let's continue to the next question. This lesson is recorded. You'll have the chance to watch this over and over again. When you watch this video, you need to make sure that you copy the questions from the beginning and you copy the answers as well, so that it can be easier for you to revise. All right, something very nice and easy, but something on a lighter note, the examiner is giving us something to end this exam paper. Right, they're saying consider the trigonometric expression, this one. We just considered, we rewritten the expression as a single trigonometric ratio for which value of x in the interval 0 to 90 degrees will this one have its minimum value. For which value of x in the interval 0 to 90 degrees will this one have its minimum what? Value. Between 0 and 90 degrees, we're looking for the minimum value of that. Okay, let's just check that one. So it's 5.5.2. Right, let's check 5.5.2. Five point 5.2. So which is 16. The sine of x cosine cubed sine x cosine x. We've already proven that this is the same as to the sine of 4x. We've proven that. Right, so the minimum value of this, the minimum occurs at, right, so the minimum occurs at the point where this 2, the sine of 4x, is going to have its minimum where it is minus 2. Okay, so because you watch the amplitude of this. Right, so the amplitude, this becomes the amplitude. Right, so if this one is the amplitude, so this is going to give us that minimum there. Right, so if this is the minimum, then you divide through by 2 and you have the sine of 4x. You divide minus 2 by 2, you get minus 1. When you get this, then you need to solve this equation. How do you solve this equation? Right, so this equation now you need to look, you need to use the Cartesian, the Argand diagram. You need to use the cast rule to solve this because you need to write cast like this. After you've written cast, where is the sign? Negative. So the sign is negative in the third, but it's also negative in the fourth. Right, so it means that first you must get the reference angle because you must get the values of x. You're looking for the values of x. So, but you must find the values of x, always get the reference angle, which is arcsine of 1. Right. What is arcsine of 1? It is exactly 90 degrees. Okay, it is exactly 90 degrees, and you get that one. Okay, once you get the 90 degrees, what you do, you consider 90 degrees and you use it to get the rest of these, for example. Okay, right. So you will have to see that at this point, what does this mean at all? So it would mean, therefore, that you'd have to say 180 degrees. Right, so you'd have to use 180 degrees, but also you need to use 360 degrees. So you'd have to say, for instance, 4x would be 180 degrees, right, because 180 degrees is here. Then you add this angle here. So if you add 90 degrees to that, you add the reference angle there. Right, and then when you add the reference angle, what you get? So you get 4x is equal to 270 degrees. If you divide 270 degrees by 4, what do you get? Let's just check that. 270 divided by 4. You get 67.50 degrees. And that's the answer. Right, so you get, yes.
Why aren't we using the K plus 360?
All right, yes, why aren't we not using that? Because the K plus 360 is for the general
solution.
But what did they want here? They said we must solve for x, where x is between something. Let me just check again. Right, so let's see here. They said for which value of x we must solve for x in the interval between 0 and 90 degrees. Will these have its minimum value? X an element between 0 and 90 degrees. So which means at this point, you need to say x is an element of the interval between 0 and what? And 90 degrees. Right. So if it's between 0 and 90 degrees, it's 60. So because we need to find the answers in this interval, so we don't add 360 by k, because it's a specific, these are specific answers. All right. So for example, the answer we must just check is the answer between 0 and 90 degrees. 67.50 is smaller than 90. It is smaller than 90. So yes, so this is correct. But now, obviously, this one is here. But now you must try this one as well. So let's try the other one. But we expect it to be outside the 90 degrees, to be very large, but let's practice. Right, so we say, we use our reference angle, so it's going to be 360 degrees. Then we minus 90. What is 360 minus 90? Okay, that's nice. It's 270. And then if you divide 270 by 4, is what we did here. It's exactly what we did here. So if we divide, so x becomes 270 degrees divided by 4, and it is what? This? So it is exactly the same results that we got. It makes no difference. So it is 67.50 degrees. And that's what we got. This 67.50, is it in the interval here? Yes, it's smaller than 90. It is smaller than 90, but it is bigger than 0. Smaller than 9, but bigger than 0. So yes. So what do we tell the examiner in metric for us to get the level 7? We say, Mr. Examiner, x is 67.50 degrees, and you get level 7 in mathematics, and you get 100%, and you go to varsity. Okay. All right. Now, that is what we had to do there. All right, so just take note of that. This is how the question to be done in the metric paper of last year, 2022 November. But it said this lesson is being recorded, so you'll have access to all these. Okay. So yeah, in a couple of, it will take me about 30 minutes to upload these, because it's 30 minutes for the program to save everything, because now it's still recording when we're talking. And then now for the program to send me the recording, it takes like 15, 30 minutes. And then I'm going to upload, okay? And then I'm going to send you the link on WhatsApp of the video, and then you can watch it for the whole year, okay? Of our discussion today. All right, so that's what we got, and this is the trigonometry. Remember, that is 5.5.2, where we said for which values of x in the interval will these have its minimum value? We got that one. The next question that they set on trigonometry for the matrix of last year was this one here. It was the trigonometry question. Let's look at the trigonometry graphs, because they're coming in the prelims this time around. Question 6, in the diagram below, the graphs of f of x, which is the tangent of x, and g of x equals 2 sine 2x, are drawn for the interval x between minus 180 and 180, and A has the coordinate 60 degrees and K, so there is the point A, and B are 2 points of intersection of F and G. Right, so these are the 2 points of intersection of F and G. So we have the points A and B. So there's a point A where F and G intersect, and there's this point B where the function F, and the function G intersect, or where they meet there. Okay, we are good. So let's just proceed now and do more. Right, so let's continue. Write down the period of G. What is the function G? The function G is this one. So it is 2 sine 2x. So what is the period? So the period of this is exactly 360 degrees divided by the coefficient of x. So it's 360 degrees divided by the absolute value of x, divided by the absolute. Which is 180 degrees. Write down the period of G. So the period of G is 180 degrees, and you get 1 mark there. Okay, next question. Calculate the value of K. So let's look at the value of K. Right, K is sitting here. What is the value of this K? Because it is the y coordinate of the point A, but the x coordinate of the point A is 60 degrees, and we just need to get the y coordinate. But it is the point of intersection of the 2 functions, so you can use any of the 2 functions to do this. So the easiest one would be this one, the f function. Okay, so let's deal with the f function. What does the f function do? Right, so it means that you have f of x, which is the tan of x. All right, so we have the point A with the coordinates, this one in K, so with x and y. So which means with K equals the tan of 60 degrees. Okay, good. Then what do we get out of this? What we're getting is that this triangle is 60 degrees here, it is 30 degrees there, it is 2, it is the square root of 3, it is a 1. All right, so using SOHCAHTOA, so now at this point, we have the tangent, which is opposite over adjacent. Right, opposite 60 degrees is the square root of 3. The square root of 3, the adjacent is 1, which is the square root of what?
1. Okay.
Okay, so that's the K value. And that's what I wanted. What is the value of K? It's exactly the square root of 3. Right, the next thing to do is to write down the coordinates of the point B. Calculate the coordinates of B. Right, so the coordinates of B are also to be found. Let's deal with the coordinates of B. Here is the point B, and it's sitting here. Okay, if this is the point B, you can see symmetry. There's some distance of the same size from here to there. Okay, let's see what this means for us. So it means that from 90 degrees now you switch back. So this was like 60 degrees. And what is the distance here? The distance is like 30 degrees. Okay, because if you say 60 plus 30, okay, so if you say 60 degrees plus 30 degrees, what do you get? 90 degrees.
90.
So So now you have the same. So now you'd have to allow a distance of 30 degrees. So if we have minus 90 degrees, then we have minus 30. So what is this? Minus 120. So you have minus 120 degrees. So you have minus, so you have minus 120 degrees, all right? So that is the x coordinate, and then we just need to get the other one. So we already know the k, because we already know that k is the square root of 3. And if you measure the y value here is just the square root of what? The square root of 3, so this is the square root of 3 as well. Right.
Okay.
Okay, so we continue. Hey, I lost track of time a little bit, but yeah, we are pretty okay. All right. So we found the coordinates of B. What are the coordinates of B? So in 6.2.2, the coordinates of B are minus 120 degrees and the square root of 3. Write down the range of 2 g of x, twice g of x. So let's see this one. All right. So then now it's easy to do this because if you look at the range of the function g, it is the square root and then it is minus. No, okay, that's not what I want to say. Obviously, you have the square root of 3, but I want to look at the actual amplitude. So the actual amplitude for the function g, you can see it on the graph. So it's going to be minus 2 here, and this one here is going to be a 2 exactly. All right, so it's this number for the function g. Now, if you want to get for twice g, so you'd have, what is the function g? 2 sine. So 2 by 2 is 4 sine. So this is the range. So the range is, it's easy. How do you see the range? So the range is a set of y values. So it's going to be y element of. So you start from -4 to 4 because of this 4. Okay, but there are different ways of doing that. Like if you look at 6.3, somebody can look at the function g of x and say the range is the following. You can say the range for g. So you do this. You say range for g, which is y element of the interval from -2 to 2.
So the value of x is
Yes.
not also affected by the multiplication of the two.
Okay, that's a good question. The value of x, obviously the value of x only stretches the graph vertically. Okay, so it affects the amplitude. Okay, we're going to discuss whether it affects x, but obviously for the range is only interested in the y values. And so, for example, yeah, if I'm looking at the range, I'm looking at the range of the g. The g is between -2 and 2, but the twice g is going to be what? The twice g, it's going to be y. So you multiply -2 by 2, and then you multiply 2 by 2. So ideally, it therefore becomes -4 like this. Okay.
Okay.
All right, so that's what we get. This is in 3. All right, so write down the range of this. For which values of x will this one in the interval these? For which values of x will the difference be less than or equal to 0 in the interval between minus 90 degrees and 0? Okay, so let's look at that one. Right, so between minus 90 degrees and 0. Okay, 6.4. Let's look at that one. So we're going to have that. G of x plus 5 minus f plus 5 minus f x plus 5. Okay, so you have that. So G, you add 5, and F, you add 5, and the result is less or equal to 0. But the area of focus is between minus 90 and 0. Okay. Now, if you say minus 90 and 0, now, if you look at these carefully, you are really therefore saying the difference between the functions f minus g is less or equal to 0. So but you are focusing between minus 90 and 0 degrees. So here is minus 90 and here is 0 degrees. And you are really saying from here to there, the difference between the functions is negative or 0. So what does this mean? If you're subtracting two numbers and you're getting a negative. So the examples would be you're subtracting 1 or 2 minus 5. You're subtracting a bigger number from a smaller number. And then the result becomes a negative, which is less or equal to 0. Okay, right. So now with this, we are therefore saying the function g is this one. The function f is this one. Now, we are saying f, but you can really see here that f is below and g is below, excuse me, and f is above. Okay. So if you say the smaller one, the one below is smaller. So if you say the smaller one minus the larger one is less equal to 0. So you'll have a negative. Okay. Now let's cut to the chase here and get the answer, what all this means. So the examiner has just moved, because if you add the 5 degrees, it means you are moving the graph 5 degrees backwards, 5 degrees to the left. So if you say x plus 5 degrees, it means you are speaking of a translation of 5 degrees left to the left. Right. So it means, therefore, the graph is going to move 5 degrees to the left. Right. So if this graph moves 5 degrees to the left, it means that, for example, at this point here, it's going to be at minus 95. Here, but both graphs. So here it's going to be at minus 5 degrees. Okay. Yes. That's what we get. So the question then is, what happens to the points of intersection and the area of interest? Because now you need to look at what is happening, but most importantly, you need to say, where is G smaller minus bigger? Smaller minus bigger is negative. So G is smaller here, because now G is bigger here. We don't want it when it's bigger, we want it when it's smaller. So G is smaller here. So it is this section, but this is going to be such that now you need to analyze what is the original point of intersection, so that you can realize that it's going to move by 5 degrees left. Everything is moving by 5 degrees left because the examiner is adding 5 degrees. So if you say 5 degrees left, what was the original point of intersection? So you need to realize that there's symmetry, that the distance here is 30 degrees. So this is going to be like 30 degrees. This is going to be like how many degrees? 30 degrees. Right. So if it is 30 degrees, then what do we then get? It was minus 90 here, so this is going to be like minus 60. Minus 60 degrees, but now you move it 5 degrees left. So it's going to be x 5 degrees left. So it's going to be minus 65 degrees. But also this one was at 0 degrees. Now it's going to be at minus 5 degrees because it's moving 5 degrees left. So minus 5 degrees there. Okay, just that kind of thing. So just note that. Okay, right, we continue. We continue by solving these questions here. All right, so we look at this one. So what is the answer here? So x is an element of the interval, minus 65 degrees, minus 5 degrees. All right, you think about it, and then that's the answer. Okay, let's look at 6.5. Determine the values of P for which this one is the case. So at this point here, determine the values of P for which the sine x times cosine x equals P will have exactly 2 real roots in the interval between minus 180 degrees and 180 degrees. Right, so we're dealing with the trigonometric sine of x times the cosine of x equals P. And now you need to study this. But let's look at the graphs. Right, so if the examiner gives you the sine times the cosine equals P, look at the graphs. Which graph is sine times cosine? None of these graphs, but this graph is very close to that. It's very, very close to that. Okay, so in other words, you're getting, it was obtained from this one. So how was it obtained from this one? So ideally, it means that the examiner just wanted you to multiply this by 4. If you multiply the left by 4, you have 4 sine x, and then you multiply the right by 4, you have 4p. All right, after this, the 4 can be split into 2, because we need 2 sine x cosine x, which is 4p, which is the sine of 2x equals 4p. So all right, so you're getting this. Now, we're interested in the values of p. So, what does this mean? Between minus 180 and 180 degrees, this is equal to 4p. It means that when you have 2 real roots, so it is the graph of g, and this 4p is the line that is either like this or, but if it cuts here 1, 2, 1, 2, 3, 4 points. So it cuts at 4 points, but it must cut at 2 real roots. So it must touch at 2 points. At the turning point. It must touch at the turning points. So now the question the examiner is asking, what are the values of p? So it must touch it. If it touches at this point, what is the amplitude of g? The amplitude of g is 2. But either it touches above or it touches below. So, okay, this has become so untidy. Let me clean up a little bit. So you would say it will touch, if it touches here, or above, it will touch 1, 2, or there. Here at this point, the minimum is minus 2. There, the maximum is 2. So, okay, it's an interesting one. So we have already seen, therefore, if you multiply by 4, sorry, it becomes this one. Multiply by 4, you split the 4, it becomes 2, 2. Sine x cosine x equals 4p. In these, what is 2 sine x? Cosine x, it becomes the sine of 2x is a double angular formula. So which means that for p is plus or minus 2. So now, because here you consider the max, the maximum is 2, and the minimum is minus 2. So you divide. So which means that you have plus or minus 2, divide by 4, which is plus or minus 1/2, you divide by that. So p is plus or minus 1/2. So what are the values of p? So either p is 1/2 or p is minus 1/2. Okay, so these are the 2 answers. These are the 2 answers.
Okay.
Right, so they asked us to find the values of p. So they said determine the values of p for which this will have exactly 2 real roots. They said the 2 real roots will occur when the line whose equation is 4p touches the graph at 2 points. And this can only happen if we allow the line to touch at minus 2 at the minimum through the turning points or at the turning points. Because if you let the line touch in the middle, Then it's going to cut 1, 2, 3. Okay, so you have obviously got through the x-axis, it will cut at 1, 2, 3, 4, 5, perhaps, something like that. Okay, so, but we're interested in 2. So it must touch at the turning points. All right. And then now we continue and solve a bit more problems. Right, let me load another question for us to practice a little bit, because we are having the opportunity to practice. Right, let me take an image. From the gallery. Right, so from the gallery, I'm going to take this one. Right, so let's look at this question here. Right, so okay, I need to stretch it. Good, need to do further stretching of this. Good, just a little bit more. Too much stretched. See what, make it a little bit. Okay, see. Yeah, this is okay. Right, so let's just get cracking again. Right, so we're looking at question 7 right now, and now question 7 is a very interesting one. It is solving the sine rule and the cosine rule. Right, AB is a vertical flagpole. That is a square root of 5p meters long. And then we have AC and AD are 2 cables anchoring the flagpole. B, C, and D are in the same horizontal plane. B, C, and D are in the same horizontal plane. BD is 2p meters. BD is 2p meters. And ACD is X. ACD is X, this one here. So that's A, C, D, and that angle here is X. Right, so we have something like that. Okay, just familiarizing ourselves with the shape and the figure. ADC is 45 degrees. ADC is 45 degrees. All right, determine the length of AD in terms of P. The length of AD in terms of what? In terms of P. Right, so this one is very, very easy to do. First and foremost, so to do the 7.1, we know that, so we have this triangle here like this. And then this is the square root of 5p, and then this one is 2p, and then this is 90 degrees. This is y, and this horizontal one is like x, and that is r. So we know that x squared plus y squared is r squared, and this is Pythagoras. So which means x is 2p squared, and then y is the square root of 5p. 4p squared. 5p squared is r squared. You add them up, which is 9p squared, which is r squared. Now, what is the square root of 9? It is 3. Okay, so it is 3p and r is that. So you get that. So It means, therefore, that AD is exactly 3p units. Right, so it means, therefore, that AD is 3p units. Right, in 7.2, show that the length of CD is this one. So at this point, if you want to find the length of CD, you can easily determine that because you already know a couple of things, but you already know that AD is 3p, right? So if you already know that AD is 3p, then you just need to find the length of CD. But also, to find the length of CD, you already know, so you have this triangle here. X, this one here, 45, and this one here is 180 degrees minus X plus 45 degrees. And therefore, this is CDA. So you find. So in 7.2, you take the triangle like this and have A, and have A here. This one, according to the examiner, is C, and this one is D. And this is 180 degrees minus into X plus 45 degrees. So what do we get at the end of this? So we can use the sine rule and say CD. So this is how we basically we say in triangle CAD, triangle CAD, we have CD over the sine of 180 degrees minus X plus 45 degrees.
So,
yes, please.
I have load shedding now, so my network is
not so good, eh?
Yeah.
Yeah, I can see. Yeah, it's affected. Yeah. All right. Thanks a lot. Then. I will stop the lesson now. Okay. So thanks a lot. Then we'll talk then next time. All right.
Okay. May I ask how many lessons are we gonna have per week?
We need to have one minimum lesson per week, but a maximum of 2. We'll discuss that. I'll have to look at your availability, etc. But one lesson per week of 2 hours is normally enough. Okay.
Okay.
All right. I understand your network is it has changed terribly. Yeah. Thanks a lot, Waruna. Have a good evening. Okay. And goodbye.
Good night.
Okay. Goodbye. Goodbye. Good night.